couple of minutes past. Let's get started. There has been a schedule change. We have had a speaker drop out, so I have stupidly volunteered, despite the fact that at 10 o'clock this morning I had to have a sit-down shower because I was not feeling great. So we'll see how this goes. I am not going to be talking about Kubernetes RBAC much, although that will come into this talk a little bit. I am going to talk about some CI pipeline compromisey stuff that we've done over the last few years at NCC. So, this is a presentation that I gave last year at Security. A couple of you may have seen this before. There's like 4 bullet points that have changed. If you've seen it before, feel free to go and see whatever Andy's doing. If you want to see more stuff about secrets, I have stolen some. So, quick introduction. That is really bright when it turns over, isn't it? I'm Iain. I am the containerization practice lead at NCC Group. I do shiny DevOpsy hacky stuff, basically spend my time breaking out of developer deployment scenarios. We started this sort of work kind of 3 or 4 years ago, and then we had an internal meeting and went, actually, we've done quite a lot of this. This is quite cool. We should probably talk about it somewhere. But it very quickly became one of those, like, well, we don't think it's... You do this day in, day out, and you go, well, it's nothing special. And then you talk to people, and they go, I have not thought about this. So hopefully some of you are going to learn something here. I'm going to do a very brief introduction to CI/CD. Is anyone familiar with CI-type stuff? Got a few people. Excellent. Very quick overview then. We don't need to spend too much time. Then we'll talk about some of the attacks we've done in the past. We'll talk about some blue team advice, some of the things you can implement on your side to stop people like me doing things like we're going to talk about. Ever so slight disclaimer. I do tend to skew towards container-heavy findings. That's where my background is. Given that the schedule had this as a Kubernetes talk, I'm assuming people are okay with this. There's a kind of weird mix of technologies, but I have a skew towards AWS and containers. So if I say an EC2 when it's Azure, I'm sorry, it's still an EC2. It's the same thing with a different name. Also, we have redacted just a little bit client confidentiality, make the stories a little bit more interesting, because I don't want to just put a report up on the screen. So, very quick overview of CI/CD. Effectively, it is a magical way of making code, go through some tests, and end up in production without you having to do all that copying and pasting and SCPing and whatever else people did before CI. It's basically a bunch of methods of running scripts, fundamentally. It's a bunch of for loops that do the same things over and over on a trigger. The theory behind a lot of CI work is it makes your developers faster and more consistent. What we actually see is a lot of customers spend huge amounts of time building platforms and not writing code. I know I do that for when I was writing this talk originally, I was trying to do like a cool way of live hacking the own CI/CD pipeline that modified the slides. And that's a disaster because if anything breaks, your slides just don't work. So I did not do that. The actions that we get are generally performed against a central code base. So developers are doing some bits of work on their own machines. They push that into a central repo in either, hopefully not just the main branch, but in a Git branch. You've got consistent actions being applied every time a commit happens, every time a developer pushes some code on a schedule, however you want to do it. And in theory, this does make the devs more efficient because they don't need to worry about remembering to run testing and that sort of thing. A little bit of terminology. I consider CI continuous integration and CD continuous delivery or deployment. So the CI is generally the bit before you copy the code. It's your unit tests, your security scanning, that sort of thing. CD is the bit where you just copy code and it ends up in a server. The exact use of a lot of these phrases varies depending on who you're speaking to, which is wonderfully helpful when you're doing research because no one can really agree. For the purposes of this presentation, CI is the stuff that happens when you make a request before the code actually starts running somewhere. And the CD is what ultimately gets the code to the point where it will run. The theory again here being you can add in a lot of tooling before something's deployed. So rather than what it used to be, which was, hey, we've been developing this for the last 6 months, please come and pen test, you can bring some security tooling in sooner. You can add in things like static security scanning, secrets checking, vulnerability scanning way earlier in the process. And if you built this right, you can give your devs a magic way of fixing things without them having to spend too much time. Or they get the feedback quicker, they don't need to worry about rerunning their entire processes the whole way through. In theory, more testing, smaller changes, faster feedback, you don't have to spend months and months and months rebuilding everything each time. Why has Siri started listening to me? It's trying to transcribe my talk. That is wonderful. I didn't get that. Could you try again? No, I cannot. Continuous deployment is basically the bit where the code's all ready to go. Right, let's fire it off to a server. In theory, your code shouldn't going straight to prod. It should be going to a test environment. More mature customers have multiple environments, hopefully running the same code base. And we will talk a little bit more about that later because it's quite an important point from a security perspective. So, what tech do we see? In pipeline stuff, we normally see Jenkins, GitHub Actions, GitLab CI. There are a few others. There's a huge range of these bits of technology. Everyone's got their own one. They kind of just throw a dart at a board of them and go, yeah, I'll use that one this week. They all basically do the same thing. Fundamentally, all of these pipelines are remote code execution as a service. I give you some code, I stick it in a repo on a computer somewhere, it goes, I will run that code, thank you very much. What could go wrong? And in terms of the compute, we see a mix. So you can have VMs or bare metal machines, you can have containers, which we see fairly regularly, and you can see some serverless platforms. We've seen some customers do this in serverless. Ultimately, it doesn't really matter. It's still the same code running on a machine somewhere. We kind of don't care. And that's part of the charm, is you've got this abstraction layer of, I write code, a computer somewhere runs it in a way that we know is reproducible. I don't need to worry about my laptop versus someone else's. From an attacker's view, code goes in and hacks come out. This is great. This is exactly what we need. Generally, the pipelines are really, really privileged. So if you're deploying AWS components using something like Terraform, the chances are what you've done is given a service account somewhere, AWS admin. Because if you don't, it breaks randomly halfway through deploy and doesn't tell you what permissions have failed. So we see all the time these components have loads of permissions. They're literally designed to make code run in production. That's the whole point, is they take the code, they put it in your running environment. Great. As an attacker, if I can get in at the start of this process or the middle of this process, I can just use those pieces, those credentials and so on to just put my own code in prod. So as a very, very quick example, we have a wonderful diagram, which is basically GitLab talking to something like Kubernetes, and you say, hello, I have had a deploy, the code's changed, please, redeploy a pod. And then Kubernetes takes on from there and does its magic thing. We will not go into that. I could talk for hours. So the syntax, and I'm going to use GitLab basically because it was the easiest one to get up and running in my home lab when I was building this. It's all in YAML. So if you're not used to YAML, I'm hoping you all are, and I'm hoping you all share my hatred for it because white space sensitivity is a wonderful thing. Basically, you write, where that laser might show up. You name your job, you put a stage, so you can have like pre-prod testing and deployment as different stages. One stage will only run if the other one has passed, that sort of thing. And then a really basic example, hello world, I'm doing some testing. When you click run, that will look something like this, which you absolutely cannot read because it's tiny. Basically, we have evidence of the job running. There's the tasks that ran, and up here in that tiny bit there, we can see it's actually echoed out hello world. For anyone who did the control plane CTF yesterday, you'll have seen this because it was very, very similar to the GitHub Actions that they were using on the CTF. A bit more interesting of an example would be something like this. So you've got a developer. They do a commit to Git. Git then makes Terraform do something. For example, the Terraform then creates your S3 bucket, which has your source code in, and then the Lambda builds up off that. That would look a little bit more involved, but basically it's the same thing. You've got a few bits here like rules. So you can say, I only want to run a job on a certain branch. I only want to run a job if the developer was a certain group, or various other options. There's a lot. There's loads of documentation out there. It's boring. And then we basically said, right, cd into the Terraform directory, Terraform init, and you'll notice we're specifying like a Terraform state. So that's basically where Terraform keeps what it knows about that's already been deployed. And we say Terraform apply, just auto approve it. I'm sure it'll be completely fine. Using a Docker image hosted on a test environment, and only do this when someone's written changes to Terraform. So you probably don't want to be redeploying your entire environment because someone's updated the README. So having some rules like this are a really good idea. So basically that's all you do. You've got some code, developers commit their code, you've got access controls on the repo, hopefully, and then a computer somewhere goes, oh, this looks fun, I'm going to run some code. We spent quite a while with various customers pretending we were developers and just trying to find out what was possible, because a lot of customers go, oh, it's fine, our devs are fairly trusted, but we want to know what they can actually do. The answer is quite often quite a lot. So I've got 4 stories of this, of varying approaches we used. The first one was probably the first CI job we did as a company that I was aware of. We were told, hello, be a developer. We've got this Java app. Our devs can work on it. We want to know what's going on. We come in and go, okay, let's have a look. Not brilliant with Java, but can muddle through. It was an Apache Maven project, and we could specify dependencies. So we could say, when you're building, load in these other Java files, and I'll make them run. Great. The customer didn't have any restrictions on their network at all, so we could just write our own malicious Java. We did a really, really, really advanced thing of generating an interpreter payload and Metasploit with no obfuscation or anything, hosted it on a server over HTTP and went, I wonder if this works, and we got a shell. So, brilliant. We have an interactive shell in the customer's build environment. That's great. Thank you for the woohoo. Someone's listening. That's fine, but we were in a relatively restricted environment. It was cleanly spun up just to build this project, and then it was destroyed again. So, great. We already could modify the code because we were developers. We hadn't gained anything yet. At this point, we started... Oh yeah, interpreter. Good. I got ahead of myself. We started doing some recon. What's available? What's in the box? Because a lot of the build environments are quite small, because they're only meant to build one thing, there's not really much there, so your recon becomes much easier than if you'd jumped onto a huge customer build environment that's like building loads of projects and has everything everywhere. We did a search for secrets, and literally just cd ... let's see what we find. We found an SSH key, a private key, not a public key. To this day, neither I nor the customer know why this key was there. As we're about to see, it should not have been. So we've got an SSH key. Where do we use it? We installed Nmap because we had unrestricted internet access. We could just put whatever we wanted in. So we nmapped around. We found some servers that were listening on 22, and we went, we can probably guess what we're doing here. We've got an SSH key. We've got servers listening on SSH. I wonder what... Oh, we're root. Okay, we can SSH around the estate as root. This customer was using Jenkins. I'm guessing some of you have used Jenkins at some point before. We could SSH to the Jenkins master nodes, which are the ones that control the scheduling, the secrets management, and the deployments of every single job across the customer's entire estate as root. So at that point, we're just like, hey, we're just going to see what secrets we've... Oh, look, there's all your AWS keys. There's all of your signing keys for your mobile apps, everything. Just sitting around. Bearing in mind, we were given access to one repo as a developer, not admin of the repo or anything. So we had a fun readout with the customer. They were like, what have you actually compromised? And we went, what do your devs work on? All of it. We have compromised all of it. This is not great. Trying to piece together how that worked. I mean, it's very easy to talk about these attacks at the time, right? But it took us I'd like to say this took a while. It probably took a couple of days by the time we did the network scanning, tried to work out what we were looking at, but it was quite a smooth attack in the end. The next one was a different starting point. So our red team were doing a job, and they were making not very much progress for a while because they were going, right, we've got a couple of user credentials. The customer was in a fairly non-Windows environment, and generally a lot of our attack paths are Windows focused. So we went, right, what can we do? We've managed to get into this pipeline. We basically compromised a developer, so rather than being given creds, we found creds and went, what can we do? Found this repo that looked like it was doing something fairly juicy, and went, I wonder if we can just modify the build scripts. So we told it to run Printenv, which is just dump all your environment variables. The good news is most of these CI platforms, if there's anything that you've marked as sensitive, obfuscate them, so they put stars or they put the word redacted or something like that, which is really nice because no one can just read these out of the logs. The less good news is if you run Printenv and pipe it to base 64, the obfuscation doesn't know, so you just copy that out to base 64 decode and you get the values. We found a service account credential for their Windows estate, Active Directory user. We went, I wonder what this guy... It was domain admin. Literally, we were ready to do all these really cool escalation paths across the estate and start trying to work out what we could do. No, we found domain admin creds in an environment variable in a build. Amusingly, the customer messaged us and went, why are you messing with this repo? Because a build failed. And they got an alert to say, because our build didn't actually do anything, they went, hey, the pipeline's failing. And we went, oh, sorry. We're burned now. But we didn't go, oh, sorry, we've got domain admin because of it. Oh, sorry about that. They didn't know until the report was delivered just how bad this was. So that was fun. That's a fairly short story. There's not much to say. We found domain admin creds lying around. Number 3 was a bit more interesting, though, because we started this job not expecting CI at all. This was a network infrastructure review. And we went, okay, we're going to scan around the network, and we found this web app and went, chuck some automated tooling at it, go off and look at something else. Turns out the web app had a local file inclusion vulnerability and a server-side request forgery vuln. We actually found out later that this app was being built and tested at the time that we were doing our scanning, and we were scanning their runner environment, and for reasons we genuinely do not understand, there's a lot of this. The app was just exposing its own port while it was being built and tested, so it was running for unit testing and anyone on the network could talk to it. This customer used Kubernetes for their testing environment and their build environment, and for those of you who aren't familiar, Kubernetes by default does this wonderful thing where it puts service account tokens into every running container. Those service account tokens can then be used to talk to the Kubernetes API and do some authenticated things. By default, not very much. If you've cocked up your configuration, quite a lot. I think you can probably see where this is going. So the token, this could easily be a whole talk. Funnily enough, Kubernetes RBAC. That is why some of you are here. I'm not going to do the entire other talk, but basically, the service account token lives in a predictable location. We used the local file inclusion, grabbed the value, got the token, spoke to the API. And then we started going, right, what can we actually do? Let's enumerate our permissions. And this is the part where I go down a real rabbit hole and I take a tangent to my tangent and talk about AWS EKS. EKS uses this, it uses a config map, which is basically a way of passing data into a running container. Or to a container as it starts up, more accurately. It uses this config map to specify which AWS ARNs, which roles across all of AWS are allowed to log into a cluster and what permissions they can have. The service account tokens across their entire cluster, every single one of them could modify this config map. So we went, that doesn't sound brilliant. Wonder what happens if I just chuck my personal AWS account in there and say any user on Iain's account can log in as admin. Yep, that worked. Wonderful. Again, we'd only popped the build environment, so we're like, well, what do we do here? We did have access, though, to every single job that was being built by this particular team because it was a shared cluster with multiple projects. Again, bear in mind from this, we hadn't even started with credentials. We were on the network, and that was it. We had access to quite a lot at this point, but we went, I think we can just get slightly more. Just production would be nice. It's always fun. So, yeah, cluster admin over the clustered, because I didn't fix that typo despite giving this presentation multiple times. The application was in this build environment. That's fine. What we were then able to do was see what other jobs were being built in the cluster. And because these clusters were, or this pipeline was designed to take built code and then send it on to production, we were able to actually modify the image as it was being built and then pass it into the production container registry at the end. Because, of course, that's what the pipeline's for, right? That's not a problem. It's by design, but no one was meant to have these secrets. So we modified the source code of the app so that every time it loaded up a certain page, it did a console.write hello NCC or something that lets us prove that we've got access without rickrolling all of their users, as funny as that would have been. And then, as I say, AWS keys to the Elastic Container Registry. The production cluster was doing something a little bit weird that we hadn't seen at the time. It was using pull-based CI rather than push-based. So rather than I say, I have this app, I would like it to run in the cluster, something in the cluster was constantly reaching out and saying, is there anything new for me to run? From a security point of view, that's kind of better because there's no, if I'm in a position where I can modify the thing that's reaching out, I've already won, right? So there's not really an escalation there. However, it was just looking for new versions of any image to run. So the automated process looking for a new version went, I'll just grab this compromised version. This is fine. I like this new shiny version. Deployed it for us. Great. At that point, we were able to speak to the customer and say, hey, can we actually just get access rather than trying to build this out? Because we've proved we can do it. You've got the evidence. What could we actually do? Basically, from the path of the pipeline up to the cluster, the ECR images that we could replace included, they were hosting a bunch of core services for their cluster, which ran with admin across the entire estate because they had to. And again, this wasn't a security problem that these images were privileged. The problem was we could replace them. And then we've got a malicious image doing something. And again, we got access to all of their secrets, all of their database keys. Basically, domain admin's nice, cluster admin's nice, but customer data is really what the execs get scared of. So, a lot of the time you go, oh, we've got domain admin, and a CEO or a CTO will go, so what? You show them a scan of their passport and a list of all the transactions their customers have done in the last hour, and they crap themselves. So we had access to all of the production stuff. We profited. Happy days. Yeah. Again, you can imagine the readouts for these, because an awful lot of them, it's why is this like this? And the devs go, we don't know. We're not really sure. Someone did it that way at one point, and it's still the thing. And one final compromise pipeline. This is probably one of my favorite stories about this, because it includes a customer saying, you can't do that, it doesn't work, when I told them I could do something. I tend not to be in the habit of making claims about something I can do to a customer's face when I can't do it. If I am going to do something like that, I'll caveat and say, I think I can do this, do you want me to try it? I said I can do this, they said, no, you can't, it definitely doesn't work. There's protections against this. I love these customers. I'm genuinely upset that this was a remote job and I wasn't face-to-face with the customer for this. So this customer was using Gitlab, but they were using Circle CI for their computes, for their actual running of the pipeline. So Gitlab was just storing the code. Developers in this customer's production environment had no access. No SSH, no network access. They couldn't log into the databases. They couldn't even access the apps in any other way than the customer-facing customer.com app. They also didn't have keys for AWS. There were a few break-glass accounts and there were a few people that had access, but this customer made really good use of development environments. If anything breaks in dev, or if anything breaks, you recreate the situation in dev. That way your devs don't have customer access, customer data. So that's all quite good. There were jobs which ran on different branches. So anything that went into production had to be merged into the main branch, which required multiple users to approve the request. Again, this is fairly good because even if I compromise a dev, I still need I need 2 or 3 other people to approve my requests. So now I need to compromise an entire team, and that just becomes more, it's not impossible, but it's more difficult. What's a little bit more interesting though is where Circle CI came in. The pipelines were configured through a circleci.yaml file, and again, YAML, everyone loves or hates it. There were secrets in there that were set as environment variables, but GitLab lets you protect secrets per branch. Circle CI doesn't, and that's basically where this is going. The environment variables are designed based on which branch has been built. So, for example, don't know how well that shows up for the people at the back, but basically, if you're doing dev things, you use the Terraform image, and you use the dev AWS key and the dev secret access key. And that's on any branch where the branch name is feature/dev something. Again, the developers could do whatever they wanted with these because they're not the production branches. It's literally for a playground. And in production, you do prod things with the prod keys. This is fairly good, right? If I'm working on the dev branch, I only use the dev access. There's no problem here. Developers could change anything they wanted in the non-main branch. The Circle CI config file is in every branch. The Circle CI config file is what controls which environment variables you use when. All of the secrets are technically available, even if they're not actively used, to all of the branches. So we said, I want to do hacky things. I want to, on any branch, just use the prod keys. And we didn't do any deploys or anything. We just printed them out and said, hey, I can log into your AWS now. Once again, this was AWS admin across their entire account. Fairly funny because we just went like that and then out come the things we need. Here's the keys. Happy days. The conversation with the customer after this was fairly interesting because I went, hey, I've done this thing. And they went, that's not great. How do we fix it? I said, you keep your circleci.yaml files in a separate repo and you just reference them rather than... And they went, yeah, we're not going to do that. We don't want to. That would be too much work. So I was right. Okay, what are you going to do instead? We're going to get back to you on that one. Basically what we got. I haven't heard back. That was about 2 years ago. I have no idea if this still works or not. I strongly suspect that conversations were raised internally and then someone said, can I have budget to fix this because it's going to take a while, and someone else went, I'd rather you didn't. We'll just one of the good things about these attacks is they are all logged and audited and monitored. So as on the defender side, I'm running actions in a branch that you can see. And they're running on your compute and your infrastructure. You can log all of this quite well, and there is an audit trail. There are a couple of weird exceptions. There used to be a thing where if you ran, I can't remember if it was GitHub or GitLab, but there was one where if you opened up a draft pull request against something, you could do whatever you wanted against that project. And then if you deleted the branch, all of your jobs disappeared as well, which was quite fun. And that does become a bit harder to detect. But the Printenv one is really fun. It just works all the time. The number of people who are like, that shouldn't work, but it does. Okay, great. And we've had a few others of these recently as well that I don't have slides for because I've not written them up yet. The couple of examples that I can think of, I had one large financial organization where I got a runner back from their pipelines and effectively we did the exact same attack again where we just did a interpreter shell back in. Turns out all they were doing was Azure VMs with no isolation. So if you did cd ... there was like a jobs directory and it had literally all of their jobs, source code, environment variables, whatever was in them. We also ended up writing something on that job that just monitors /proc, which is a virtual file system in Linux that has information about running processes. And we just monitored for any new process being created and dumped all of its environment variables. The customer went, oh yeah, but you can only do that on our network, right? You can't actually exfiltrate anything. Another thing that I really, really enjoy doing, and this is something that a lot of people don't think about, is Slack webhooks. Loads of people who are running automated pipelines use Slack. If a build fails, the runner sends a call out to api.slack.com. You cannot whitelist if you're only doing something based on host headers, just your endpoints. So I have a Slack workspace that has a channel called Listener, and I've got a webhook that if I send it data, it just fires into my Slack. Which is brilliant because the customer goes like, how are you going to exfiltrate data? I turn out the screen and like, I've got a Slack message with some secret keys in. This isn't great for you. The other fun thing you can do with chat ops is if you compromise an environment that does that, you can actually get the API keys to talk to the devs. I was on site once for an insurance company and they had their chat ops dashboard up on one of the big TVs on the wall. So I started sending gifts to it. And they were sat there like, what the hell's going on? Why is Rick Astley suddenly on the monitoring channel? That is quite enjoyable. And I do like when the devs are like, okay, that's not ideal and we can see why. Same thing again if you're using Kubernetes. If you've got service account mounted in, this is just a kubectl auth command that says list your permissions. In this case, I had done the wonderful thing of binding everything to cluster admin just for a demo. As Iain Coldwater said on Twitter at one point, we're all made of stars, but your RBAC shouldn't be because it's going to lead to sad times. I'm just off a job where a customer did something similar. They, all of their Docker containers ran with the Docker socket mounted in and running as privileged containers. Anyone who was at Rory and I's workshop yesterday knows how bad an idea that is. Hopefully anyone who's even thought about running containers in production knows why that's bad. Once again, every single one of their jobs could get admin on the runner. And if you run enough jobs, you can get admin on all of the runners and compromise all of the jobs. So that's it for the stories. I have many, many more of these. I will happily talk later about them if anyone is interested. Probably useful to pull some common themes out of them here. And this is where it's quite interesting because CI seems to be the new shiny thing, but it's also kind of not because it's the same problems that IT people have been facing forever. network segmentation, right? The very first story we said, we were able to reach out to a random location on the internet, download some Java, and run it. That shouldn't have been allowed. Reverse shells shouldn't have been allowed. So many bits of network access. They just really shouldn't have been possible. We regularly do compromises with cloud metadata. So quite often we see things like GitLab runners or GitHub runners being built in auto-scaling groups in AWS. When an auto-scaling group scales, the new machine needs to talk to GitLab and say, hello, I'm your new runner. What that means is there's normally some mechanism where an enroll token can get passed to that machine. It's normally through the AWS metadata. So if I can write a job, I can just grab everything in the metadata, including the setup scripts. You can technically at that point enroll your own laptop as a runner on their environment. So every, however many, say they've got 3 runners, suddenly you're going to get a quarter of their jobs when you're the 4th runner. Because the system's just going to go, I'm going to use this laptop now, and you just get the secret sent to you. Instance metadata is a bit of a dangerous one, and it's really, really tricky to have things scale automatically, but not be compromised in this way. The access to things like a Kubernetes control plane should probably be locked down as far as possible. This is one of those funny ones where if a customer's running Docker and needs something complicated, they're quite often a little bit stuck because there's very little you can... A lot of the kind of advantages of doing something in containers go away when you're trying to scale them unless you use an orchestrator. But if you use Kubernetes, you end up with horrible sadness for your whole dev team. Unless you really, really, really need to do that, don't. But my customer last week is currently trying to work out how they solve this without getting Kubernetes involved. And I think what they're coming up with is going to be fun. Component breakouts. So patching is still a thing. We are ultimately running code on your machine. You need to keep that machine up to date. So even things like kernel level breakouts, if you've got some level of isolation, or using privileged containers or Docker in Docker, we see that regularly. It's normally a fairly trivial breakout to someone who knows what they're doing to gain access to the underlying runner. Same VM for multiple projects. Hopefully you all know why that's not a brilliant idea. It does happen quite a lot. Worryingly often. And yeah, just anything that you kind of... Thinking about the trust boundary, I'll say later, I think the big problem we see is people haven't threat modeled these environments and thought about what could happen. People just go, oh, it's fine, the jobs are isolated, but never stop and think what happens if the jobs become not isolated anymore. So if you've got a customer who is deploying their entire AWS estate and deploying their individual applications into there on the same runners, you've got a bit of a trust boundary overlap there. So you've got some high integrity stuff and maybe some lower integrity stuff. Probably don't have them running on the same runners just in case someone manages to do this sort of thing and get access to all of your secrets everywhere. RBAC is tricky, fundamentally. Kubernetes especially, but anything in the cloud, anything in even just your GitHub or your Jenkins RBAC, we've seen instances where Jenkins jobs, you're like maybe able to log into them and just make a couple of minor changes. But those minor changes can include things like just read all of your secrets or replay the job, but actually instead of deploying to this server, we'll change the IP so I can use that to grab your source code, that sort of thing. Ultimately, it does come down to threat modeling and user management, which is not a new problem. None of these are. It's the same problems again with a fancy front end on. So what can you do? I realize I'm running quite ahead of time. This took longer last time because I had live demos and my lab is currently a little bit broken. Defending pipelines is basically the solutions to the problems we just spoke about. And again, none of these are new. They might just have a different name. So firewalls, you need to do some form of network level isolation, whether that's security groups, NACLs, a physical firewall, a web proxy, network policies in Kubernetes, some kind of mad service mesh, anything like that. Just don't let your build environment talk to me over the internet, and don't let me talk to your build environment. The customer where we're doing the internal inf, number 3, we had no reason to be able to talk to the build environment from the main customer LAN, but you saw the impact of what was possible because we could. That should have been a traditional network segmentation problem. Again, it's not particularly new. Just restrict access to the build environments. It gets a bit fiddly because developers like to be able to debug jobs, or they want to be able to just log into the production servers anyway to make sure things are working. And obviously your build server does need to talk to production at some point. But there are ways of making that access possible that don't result in total compromise of your entire company. Probably use those options. And the same with RBAC. Ultimately, don't run things as admin. Don't run your random pipeline that deploys a single app to one server as domain admin, because that's a really bad idea. It's 2023. Stop running everything as DA, please. Don't use privileged containers, again, is basically the same thing. System components are the same as your users, right? They are ultimately... So much of this review comes down to you've got some people that can make stuff happen and some things that do some stuff. And if I can change what's being fed in, I can make use of these permissions in the middle. Whether that's service accounts, the credentials on a VM, anything like that, keep them as lowly permissioned as possible. Try and work out the blast radius of a compromise at any particular component. So try and work out, if this Git repo gets compromised, how much trouble am I in? If this runner gets compromised, how much trouble am I in? If this AWS API key gets compromised, can the attacker just redeploy some new EC2s? We probably don't mind if all they can, Bitcoin mining or something. It's not the end of the world. If the attacker can suddenly get AWS admin, that's a much, much bigger problem. Unfortunately, tools like Terraform aren't great for telling you what permissions they need. And I think this is why there's a lot of, I'm not aware of anything in like Terraform or Ansible that says, right, I'm going to need to do these things, which means I need these permissions. There's just an awful lot of, you'll only find out when you run it and it breaks and then you need to go into your logs. I think this is why lots of people just run stuff as admin, which is, it does work. It's just a bad idea. So threat modeling. What can an attacker do? What can your developers do? At some point, assume that one of your developers at least is going to get compromised or be bribed by someone, or you're going to lay them off and forget to revoke their access. How much damage can they do before you stop them? This kind of also leads into the how do you rebuild. So a lot of organizations have bootstrapped up their infrastructure over years, and now everything's automated. But you say to them, right, what would happen if your AWS account went away? Can you actually rebuild everything? And companies that have been doing this for a long time, what you quite often find is that the automation that configures the environment configures itself. So you've got Gitlab running in an AWS account that was spun up manually, and someone went, I shouldn't really do this manually. I should be able to redo it automatically. So they just put the automation into the environment that's already there. And as a tabletop exercise, it can be quite interesting to go, you've got all of this automation. What happens if it did just die? What would happen if GitLab went away? Can you recover? And an awful lot of organizations go, yeah, we totally... Oh, no. Great. What components can you tamper with? What further access would you get? The further access thing is really the point here. You know that if you're giving a dev access to your CI, you're giving them access to do something. But just sitting down and working out which extra paths they can take, you might learn some things that you're not very happy about your own inf. And as a final one, I get asked this quite a bit, container image signing, or signing of any artifacts, really. There's been a lot of work in this space recently to make things easier to sign something so that I can confirm when I send you an image, it's the image that I built. That's great, but a lot of people do it as an automated task, right? At the very end, they go, I built this thing, I'm ready to ship it now, I'm going to sign it. If I get in earlier in the process and I've suddenly added in some malicious functionality to your code, your GitLab won't know about that because I'm a developer, right? I'm just doing dev things. This is fine. And they'll go, okay, here's some basically malware now. I will sign that for you and distribute it to all of your customers. This is fine. Image signing solves a lot of problems. Integrity of what's actually being built is not one of them. It's really good for going from the end of the pipeline onwards, but not backtracking from there. So, I have finished a little bit ahead of time. Pipelines are privileged. We know this. They are designed to be important. They can do important things. If an attacker gets in, they can do important things as well. Components really should be as locked down as you can keep them. Again, this is not new. This is the same problems that we've been having forever. But really, working out what permissions everything has, you should just lock them down as best you can. Regular audits of your job logs, your developer access, auditing basically everywhere you can. And there's this, the old problem of how much do you log and how much of it can you actually make use of. But having some level of audit trail of every time a job, especially in production, runs, anytime something does end up touching prod, you should really know about it, and you should be able to attribute that to a user and a git commit. The good thing about a lot of these attacks is they start off looking quite auditable. The problems become when I've actually compromised a runner, because suddenly I don't actually need to modify a job through Git. I can just modify any job that's running, and it could end up looking completely different to what the commits look like. And that's where actually logging on each individual node becomes important. And there's loads of companies out there that can help with it. It's not an easy problem. Good luck, basically. So, if anyone's got any questions, we have plenty of time. I am on the social media things. I am on Blue Sky, and I'm trying that. I don't know how to use it yet. I'm on Twitter. I'm here. I have an email. If anyone wants anything, I'm happy to answer questions. We'll start over there and work this way.
So in terms of privileged accounts and things like environment variables, have you seen any nice solutions to that or nice approaches?
Yes and no. So I've seen solutions that involve not storing the secrets in the repo. So a recent job I did, the customer was using HashiCorp Vault, and they were using, every GitLab job has a JWT that's injected in at build time. They were actually using the Git path. So if you're in like git.test.lab/Iain/project1, they were using the /Iain/project1 to validate the claim when you're trying to retrieve a secret from Vault. So actually it doesn't care about the user's permissions, and you're not having to keep a secret in the GitLab that is then used to log in. It's actually just programmatically creating the secret at that time to then go off and get your actual useful secrets. It does work. It's better than secrets in source code for obvious reasons. Part of the downside is your automated processes need to be automatically able to get secrets. So I've seen ways of making it less problematic. Ultimately, if you compromise one of those runners, you can just grab the jobs. So you can then use them to get other secrets. But that was one of the nicer solutions I've seen.
Would it be possible to have as part of your pipeline something that goes, oh, that looks like a cred, I'm going to look it up, see what it can do?
As in, oh, these are credentials that I've been given to make my job run. What's the impact of them?
Kind of. I don't know, some part of Jenkins, I was to look at Jenkins and goes, that looks like it, but maybe it's AD creds, I'm going to look at it against a set of groups, I shouldn't belong to.
I mean, you could write something like that. There's no reason not to. I've never seen anything that does it natively. I've never seen anything automatic do it. And I think ultimately that's probably better served elsewhere. Like at the design stage where you're going, right, we need to give this thing credentials. Probably just think about them then and don't have them be overly permissive in the first place rather than giving it admin and then having a tool complain about having admin.
Mm-hmm. Cool,
I think. Keith.
Alright, so a lot of the stories that you went through there were situations like the devs responded saying, I don't know why it was there, domain admin credentials. When you talked about trying to understand the blast radius of each component,
yep.
As a tester, do you have like a list of things that they can look for as remediations? Because, it's good saying that you should be auditing each step at a time, but when you don't know the things there, and you might have had 3 different dev teams rotate those
this is a really tricky problem, and it depends on the team actually maintaining this. If you've inherited this environment and you don't know what's there, then I guess that's the reason we do a lot of our reviews, is because customers come to us and say, we don't know what we've got, come and tell us. And there's this horrible mix of like, I can tell you that this is bad. I can't tell you why it's there, and I can't tell you what permissions you need. All I can do is tell you that what you've got now lets me do a certain thing. And at that point, at least from my experience with customers, that's where we kind of just kick it back and go, look, we've given you the impact. We've given you as best we can our understanding of where this has come from. And actually going back to what does this need? Are these permissions needed? How do we work out that they're there? Either becomes a very long, drawn-out conversation where the customer says, right, what about this? And we try something. Ideally, at this point, the customer has a team on their side that actually knows how to maintain and test as well. Or the customer kind of just risk accepts. I think, honestly, a lot of what we see is the customer just risk accepts.
So generally the answer is That's why I'm a consultant.
Pretty much, yeah. I exist to tell you all these problems and not solve them, unfortunately. That sounds awful.
Ian, on the CI front, have you ever done a test audit and come away thinking, actually, that was pretty good?
I have. It's very rare that we don't get anything. I had one environment that was completely off the internet. GitLab runners using Docker, but not with any of the scary, dangerous bits of Docker. And it was only outputting to a place that then had to be manually picked up from to actually take the built artifacts elsewhere. That was a fairly high integrity environment that was actually doing multiple levels of code review, multiple levels of technical approval to get anything put in. It's rare because most of the security that stops the attacks that we spoke about also slows devs down. And a lot of the time what we find is that these systems are put in place by the developers rather than being put in place by a central security team because the devs want to go faster and they don't want to add in that sort of security. I've done a couple where we've not been able to get very much, and we've definitely not been able to jump from environment to environment. Obviously, these are the highest impact ones because they make none of you want to sit here and hear about how I couldn't do anything other than DNS enumeration against a cluster because that's not very exciting. I've seen a few, but not many. Any? Yes, at the back.
If you're working with a client on an exploit, do you ever get picked up sort of in the reconnaissance phase, but they sort of warn the IT teams you might see some odd alerts about if you do make a note of them, but let it go, and they just want to see if you can get through to an exploit?
Yeah, so most of my environments, most of my jobs aren't red team stealthy jobs. An awful lot of what we do it's an audit that's been arranged and everyone knows about it, so you're not trying to be sneaky. I have been picked up for a couple of things. Weirdly though, a lot of people's build environments are still extremely neglected. People don't seem to realize that the security of your build environment is as important as the security of your prod environments. The runners rarely run any form of antivirus. They rarely run any monitoring. There's an awful lot of times where we just see that there's nothing that would pick us up. Or someone would need to manually go to every runner and check the logs, rather than having like an automated process in place. I'm sure there are probably customers I've worked for where they have picked up what I'm doing but just not said anything. I don't know how many. It's rare though. We'll go there.
Do you ever get any cases where the build server, the backend build server where the code gets executed is not on the client network and it's just on an ephemeral server somewhere in the cloud and
Yes.
getting spun up on demand only for compiling that code at that time?
Yeah, so I have seen instances before where every job goes to its own VM, and at the end the VM goes away and is completely not used anymore. That's great because you can't do the jump out and add another job. That is actually one of the better options, and like containerization options do provide that as well. VMs are just a bit slower, and a lot of the clouds bill you per hour anyway. So if you spin something up for a job that takes 10 minutes and have to pay for an hour, scale that across a few hundred jobs, you're not getting very good use of your resources, which is why we see multi-tenanted build environments a lot. Yes, I have seen it. I've seen people building in serverless. At that point, you stop looking for a node breakout and you start to look at cloud metadata and what can you do with the secrets rather than the nodes themselves. And it might limit you to targeting one project at a time, but you can still do something quite often. Keith?
So you brought up the sort of wealth of audit logging that you can have. You were mentioning more of periodic auditing of past actions. Is there anything you can think of within those audit logs that would serve better as an active detection to say something has happened rather than you needing to go and...
There are loads of vendors out there who will serve you anomaly-based detection stuff that goes, hey, this doesn't look right, that's weird. Possibly adding in another task to every pipeline that runs for known attacks would be a good one. So if you see something trying to talk to metadata, if you see anyone ever curling 169.254, that's probably not normal behavior, right? But at that point, you wouldn't probably want to do that in any specific pipeline. You'd want to do that on each VM or node or whatever, and just do your typical threat detection using some kind of endpoint monitoring, I think.
It's just sort of by extension process telemetry.
Yeah, so ultimately, every job you run is just a process on a server somewhere, right? So I don't think you need a specific CI-based detection. You probably just want something that does security for you. And
Find a way to convert your CI logs into a more...
either that or do it as real-time process monitoring. So it depends how far you want to go. Again, all of this comes with a cost, and it depends on how much you care and want to spend, really. I think if anyone had an actual, this solution will find every attack against your CI, we'd know about it and they'd be extremely rich right now. Especially because a lot of these attacks are quite obvious, right? So running Printenv is not normal behavior. If I really wanted to be sneaky, I'd write some code in the application that did the same thing but didn't print back out to logs or didn't send it to me. So if I compromise a web app, I'll try and add in a backdoor function there, or I'll add a page in that has some secrets printed somewhere that doesn't inherently look dodgy, and it just suddenly becomes part of a running application, and that's way harder to detect. We've never done a stealth-based version of this, partially because it would be quite difficult and probably not brilliant value for money for the customers, but also because I honestly don't think the monitoring is mature enough a lot of the time, and it's just, well, I'm going to do the obvious attacks and they'll work. Yes?
Do you find that your clients and sort of developers in general are getting any better at handling this?
No. I interrupted you there, but
I was going to say sort of anecdotally, it's kind of moved from, you have your dev team, your deployment team, things are very separated.
Yeah.
To now it's like all the time I'm just seeing everything's AWS administrator, everything's flat permissions, everything has all the secrets chucked in one repo. It's just, it feels like we're kind of regressing a little bit.
It does. A couple of customers that I've worked with regularly, they are seeing improvements because we're regularly reviewing them and pointing out the problems. But new customers that come to us for jobs we've not done before, we see the same attacks over and over and over again. Like the privileged in Docker socket mounted in a container, I saw that last week. That was a new environment that was spun up in the last few months. There are still people who are just going, this works, we want to be fast. Yeah. And then security comes along and they go, And I think it's just a lot of people just aren't thinking about it. People just don't go, I should think about the security of the build environment. But again, that's not CI specific, right? That's the same with anything that people spin up. They just want it to work.
Yeah, no, it's literally, I've seen the privileged Docker socket stuff on a client, like production environment where they were running machine learning payloads for their clients, because the clients could submit something. What
could possibly go wrong?
Yeah. Literally every sort of pod could read everything else.
Yeah. Jupyter notebooks are something we see all the time as well. Like, you're doing data science stuff, so we'll just give you something that runs in Kubernetes and literally takes arbitrary Python to do what you want with. And it always has permissions that it shouldn't have. I don't understand why.
Yeah, it was literally Jupyter Labs, yeah.
Of course it was. Any more questions? Yes.
Do you have or know of any good methodologies and resources for kind of praising CI/CD pipelines and Kubernetes and stuff?
There are many answers to that question depending on which route we want to go down. I wouldn't say I have a methodology as such, because CI is as varied as what developers are using it for. Generally, my approach is basically, I've got a malicious mindset, just put me in the pipeline and see what happens. And then it becomes kind of security principles of, again, I know I've got components that can do some things. Can I subvert what those things are doing to do something else? And that's a really high level, unhelpful answer. But it's kind of the way we find a lot of the findings, is just going, what happened? Some people go, if I press this button, something bad might happen, so I won't press it. And I think a lot of pen testers just go, press the button, press the button, press the button. And that, honestly, is what lots of it comes down to. Kubernetes-wise, yes, there's methodologies out there. Each of the individual components you'll find security guidance for, but ultimately it boils down to kind of just restrict the permissions as much as you can while we acknowledge that these things have to be automated and therefore probably aren't as secure as they could be.
So for that, the same analysis that you would use on product or environment around attack trees and threat analysis should work on your pipeline.
Oh, absolutely.
You should be doing, in terms of methodology, you should be doing exactly the same thing to your pipeline as you do to your product.
Yes.
Because you should actually be trying to work out where your permissions go awry and where your build processes can be subverted.
Yeah, as I say, these are just both business processes and literally processes on servers. So when you're designing these things, and it's easy to say, oh, just design things to be secure. If everyone did that, I wouldn't have a job. It's not something that I see happening, but just basically, so much of it comes down to, just threat model and try and design what you're building securely. Or at least understanding where the risks are coming from rather than just YOLOing it and say, haha, see, I go burr, which is what most people do.
Excellent.
Cool. Thank you, everyone. I'll be about for the rest of the day if anyone's got any more questions.
Spinning up on the
No worries.
Very good. Well done.